Imagine a bridge that repairs its own cracks, without human intervention. Sounds like science fiction? It's real. In this video, we'll explore a groundbreaking case study, the M11 Highway Bridge in the Netherlands, one of the first large-scale infrastructure projects to use self-healing concrete. We'll cover how self-healing concrete works, real-world performance and benefit challenges and future applications. By the end, you'll see why self-healing concrete is the future of construction. Let's get started. Why do bridges need self-healing concrete? Bridges endure constant stress, weather changes, and material degradation. Small cracks can lead to water infiltration, right-pointing arrow, corrosion of reinforcement, structural weakening, right-pointing arrow, shorter lifespan, frequent maintenance, right-pointing arrow, high repair costs. To solve this problem, engineers turn to a revolutionary solution: self-healing bioconcrete. Now, let's see how this technology was applied in the M11 Highway Bridge project. Project overview: M11 Highway Bridge project details. Now, let's break down how self-healing concrete works. How does self-healing concrete work? Technology used in M11 Bridge: bacteria, Bacillus pseudoformis, a spore-forming, alkaliphilic bacterium; healing agent, calcium lactate, nutrient for bacteria; self-healing mechanism, keycap 1 crack formation. Stress and shrinkage cause micro cracks. Keycap 2 water infiltration. When water enters, it activates dormant bacteria. Keycap 3 calcium carbonate production. The bacteria consume calcium lactate and produce limestone. Keycap 4 crack sealing. The limestone fills and repairs cracks, restoring structural integrity. This process helps keep bridges durable and maintenance-free for decades. Performance evaluation: does it really work? 2-year monitoring results: the self-healing concrete performed better than expected, proving its effectiveness. Key benefits of self-healing concrete: why is this a game-changer for infrastructure? Reduces crack propagation, prevents water ingress and reinforcement corrosion. Extends service life: bridges last 20–30% longer than conventional ones. Cuts maintenance costs, reduces repair costs by 40% over time. Eco-friendly: less material usage lowers carbon footprint. This technology can save billions in infrastructure maintenance worldwide. Challenges and solutions: what were the biggest challenges? Though expensive up front, self-healing concrete pays for itself in the long run. Future of self-healing concrete: what's next? Advancements in self-healing concrete: genetically engineered bacteria, producing limestone even faster. Hybrid self-healing methods, combining bacteria with fiber-reinforced polymers. Cost reduction strategies, optimizing bacteria strains in production. Scaling to mega infrastructure projects, tunnels, marine structures, and high-rises. With ongoing research, self-healing concrete could become the standard for all future constructions. The future of bridge construction. The M11 Highway Bridge in the Netherlands proved that self-healing concrete is not just a concept, it's a real-world solution for long-lasting infrastructure. Why should we invest in this technology? Extends bridge lifespan by 20–30%. Reduces repair costs by 40%. Eco-friendly with a lower carbon footprint. Should more countries adopt self-healing concrete in their infrastructure? Comment below. Like, share and subscribe for more innovations in construction and technology.